Okay. Hey, it works. Hi, stoking the flames for your content. Where is the decent hot storage? So I'm Alan, software engineer at Storacha Network. Storacha is brand new, so I don't expect you to know what that is, but we'll talk a little bit about it later. But for now, let's talk a little bit about onboarding data into Filecoin. This is a useful analogy that someone put to me a while ago now that I think is kind of useful. You can kind of think of Filecoin as this big container ship. It has lots of containers on it, and it ships data around from place to place, and it's kind of like that. So these containers are big, like they're big containers. So they're big inside. They carry lots of stuff. This is a Tamagotchi. If you don't know what Tamagotchi is kind of like it's an egg. It's kind of like a pet that you take care of. But the point is, it's very small. So you typically wouldn't fill up one of these shipping containers with a Tamagotchi. It's really small. It's not very economical to do that. You wouldn't want to put a Tamagotchi in a big shipping container and then send that off across the world. Neither would the shipping container ships want to really take just that one thing in that big thing when they could be taking more around with them. So what you might do is you might fill the container with Tamagotchis, and that's probably what you want to be doing, really. But I think what the problem I'm getting at here is that the web application developers typically have data that's not super big. They have like quite small chunks of data, like a kilobyte, maybe a few megabytes of data. They are not necessarily able to fill a shipping container. If you think about Filecoin sectors, are typically like 32 gigabytes in size. You want to kind of fill them up before sending them off on their journey in the decentralized world of storage and approving storage and stuff. So yeah, there's this inherent problem there between like the developers and the ability for storing data. So what happens? Well, aggregation typically happens. So the idea that you take on lots of data and build it up until you've got enough data to go in one of those shipping containers. So that's that. I'm going to talk about this thing. I'm going to talk about this thing called DAG cargo. This doesn't exist anymore, like at all, but I think it's a useful kind of case study. It's a thing that used to exist that we used, but yeah. So I'm going to tell you about this. DAG cargo is MVP data onboarding for Filecoin. I kind of think of DAG cargo as the A-team's van, because at the time, it was kind of like the A-team coming along to save us from not being able to get stuff on Filecoin. And so we were kind of, as a service, receiving data from users, and DAG cargo was the thing that actually took that data and put it on Filecoin. That's exactly what we wanted it to do. So that's pretty cool. What DAG cargo, so we were receiving car files. For the rest of this presentation, I will refer to car files as actual cars, but they're not actually cars. They are files, and a car file is a content addressed archives, kind of like a tar file. But typically, our clients were kind of taking their files, creating DAGs from them, and then packing those DAGs into these car files to send them off across the internet to be stored on Filecoin. So cars, kind of like tar files, you get the idea. So we were like receiving all of these cars, kept piling up like this. What DAG cargo did was kind of take out all of the blocks and the content of those cars, and it would create a giant car, magic giant car. There it is. And so the point is that this giant car was big enough to be putting into Filecoin. And so what it meant was that DAG cargo could now, push that into a Filecoin shipping container. And it just works. It was really good. I'm pretty sure the creator of DAG cargo would say something different to that, like it just about works. I had to babysit it or whatever. But for me, looking at the thing that was doing the job really well for us, it just worked. And it was brilliant. And that was a long time ago. Unfortunately, that's where the good bits of DAG cargo end and the bad bits begin. DAG cargo, as an MVP for data onboarding, you find problems with stuff like that, right? So, and we had, there was just a lot of things that we came to realize from this thing that was created. First of all, we've got lots of tiny cars, and it's made a big giant car, and that's basically, even before it's got into Filecoin, we've duplicated our data, so we've got like extra storage costs for doing that, and the process of even like extracting DAGs out of the cars and repacking them into, it creates like a directory with structure with all of this data in it, is kind of, it's compute intensive, it takes a while, you want to get it to exactly the right size, so there's just a lot of work involved with doing that. And then, what do? We put that giant car in centralized storage, so like what are we even doing? Why? We want to get away from that if possible, was the plan. It's also quite tricky if you want to remove one of these cars, like if you find out that some users uploaded some copyrighted content or something, you want to take one out, like that. Maybe it's copyrighted, maybe it's just the user just decided that they don't want that stored anymore. It's difficult to do that because you kind of then have to create a new giant car with maybe you have to swap that piece out with a different car, but it ends up being a new giant car that goes into Filecoin, and that kind of sucks. And you'd sort of want to keep these giant cars around just in case the storage provider decides to drop that data on the floor, or the deal perhaps expires. So they're just kind of necessary and duplications of extra data. So we kind of want to avoid that. The other thing is that the DAG cargo is backed by a giant elephant Postgres, the elephant in the room, and it's basically storing all of the CIDs of all of the blocks, of all of the DAGs that have ever been put into Filecoin, and it's literally terabytes of information. It's huge, it's unruly, and it's not even the data that we want to be storing. It's just metadata at this point in a big centralized place. So that was bad. Or is bad, was bad, yeah, anyway. The other thing that I think is not necessarily a bad thing, but it's basically a bunch of cron jobs that sort of wake up and do stuff. There's no real, you don't talk to this service in any way. It's not like an API you can talk to. It's sort of DAG cargo wakes up, does its thing. You don't talk to DAG cargo, it does its thing. If you want to get information from DAG cargo, you have to literally connect to the database and be like, okay, what happened? So not great. So we want to avoid that. And the final thing, probably the most important thing, is that there's no real proof that the data you've added or wanted to be stored has been added to a bigger aggregate of data. You get it's kind of a data model selector, so it's just an IPLD path through the data, so you can sort of traverse. If you can get hold of the entire giant car, you can traverse that path and then verify that your thing is there. But who wants to actually download 32 gig of data just to verify that? What you really want is an actual small Merkle proof of the fact that your particular piece of data is in an aggregate. So yeah, no proofs. Also something we want to avoid. Kind of looks like a Unix directory, so I think you can maybe look at it over the IPFS gateway. I don't know. Yeah, what are we going to do about this? We like that it just works. That's good. We want to keep that. We do want some kind of proof that something has been added to an aggregate, and just so that we can verify that and know that the data is our data is being stored, even if it has been aggregated into something bigger. And we really don't want that giant car because that's kind of yeah. Anyway, I talked about that. So what is the solution here? Turns out the solution to having a giant car is not to have a giant car. Just don't. What if we turned it on its head, and instead of compiling this big giant car that we could sort of send to storage providers, what if we sent them a kind of recipe of the data and got the storage providers to kind of pull that all of the bits of that aggregate and assemble it into something that will be stored. And so that's exactly what we do, just that realization that an aggregate is just the sum of its parts, or the sum of its cars, as you might say. And it sort of looks like, a bit like this. At the top here, we've got the kind of the CID or CID of the aggregate, and then we've got a list of all of the pieces that are that would make up that entire aggregate. So you can download the pieces and then assemble the aggregate and then verify that you have the right thing using the CID at the top. So that's kind of what it looks. And if we take a look at that CID, if you don't know about this, the cid.ipfs.tech, you can plug in any CID here, and it will tell you information about what it actually contains. This particular CID of this aggregate is a FR32 SHA-2256 trunk 254 padded binary tree multi-hash in a CID. Catchy. The important piece about this is that piece. It wasn't really intended, but anyway, it's a peace CID. It's also known as like a CommP or peace commitment. This particular CID is a special CID. This is like a special peace CID, version 2 of it, and it's actually in a FRC at the moment. Typically with peace CIDs, you sort of also need to carry around the height of the tree. So whenever you see in the Filecoin code base, or sorry, the Lotus code base or wherever, you typically get this hash of the tree as well as the height of the tree carried around together because it's sort of not meaningful. Well, anyway, you normally get them carried around together. So the cool thing about this is that those 2 bits of information are encoded into the same CID, so you only kind of carry around one piece of information. So we're using those. Anyway, that was a long kind of side quest there. But you can see these pieces, these pieces of the aggregate here. If you inspect any one of these CIDs, so this one is like ends in CII, this one is also a piece CID. So this is an aggregate that is a piece, but we have actual piece CIDs for every single chunk that's going into this aggregate. And it sort of implies that we need to move this piece CID calculation. Okay. There's 5 minutes left? Okay, right. We're going to go faster. Need to move that PCID calculation into the client. And so we can do why would we need to do that? Well, one of the things is that is for this proof that we wanted. So you can also, you can, due to this FRC, this FRC describes a way of proving, it's also known as proof of data segment inclusion, but it's basically a proof that your CID is in a bigger, is part of a bigger aggregate. And so we make use of this. And it kind of looks a little bit like this. The aggregate CID at the top, and this is the direct path that the nodes that you traverse from your CID to your piece that's in your aggregate. And it actually looks a little bit more like this. We've highlighted the direct path, but these are other nodes in the proof that are actually part of the proof that give you that verifiable information that your piece is in your aggregate. So CommP at the edge, we want to try and move this CommP right to the end. And when I'm talking about the edge, I mean like in clients who are actually creating this data. Once you've created your DAG, create your car, and then generate a piece CID for that car. And for that, you kind of need to do stuff in JavaScript. And then we have a JavaScript library that does this. It's kind of slow. In browsers, we've come to notice that I think they throttle native crypto stuff to stop kind of mining in either on purpose or by stealth in the browser. So the JS native one is kind of slow, but we've got this Rust version as well, which can compile to WASM, and you can download it and use it here to generate your piece CIDs. We've got this, so putting this all together, we can create this verifiable aggregation pipeline. So this is the idea that we can take these kind of recipes, the proof, and use it all together. And we use that in the whole of the system, but for just talking directly about the aggregation for aggregating for Filecoin, this is similar. So we start with a client, and they talk to what we like to call the storefront. It's kind of like we refer to it as the storefront because it's like the place where the client talks to get things stored. So they'll typically say, I've got this piece CID, can I get it stored on Filecoin and put in a deal? Storefront issues like a receipt. This is signed. So when we're talking about UCANs, we're talking about like signed invocations. So they're actually like tokens that are signed, and receipts are also signed. So you get this kind of nice verifiable process. The other cool thing about UCANs is they're really great for building applications with. They've got this superpower where you can kind of delegate to someone else the capability to do things. You can be really restrictive with that. So you can specify particular things that they can do. You can also specify like what arguments they can do with that. So you could say, I want you to be able to store this particular CID, so it's very, very restrictive. You can expire them, you can revoke them, so you can have short-lived ones, and etc. But anyway, so the client typically says, I'd like you to put this piece on Filecoin, sign a request, you get a receipt back. The cool thing about the receipt is it sort of points to the next task that's going to happen in the pipeline, which will be done by the aggregator. So taking that piece that you've asked for and aggregating it together. And the aggregator will eventually issue a receipt that says your piece has been aggregated into a bigger aggregate, and here is the proof of aggregation. It'll be part of that receipt as well. The receipt also has a pointer to the next task that's going to happen, which will be this kind of dealer component that will get things into Filecoin, and that receipt will be issued when the dealer has managed to get it into Filecoin. And that will go via what we call a broker. We use a kind of broker called Spade for this, and it is kind of the purpose of the broker is to kind of organize deals with storage providers. So you might want to set some parameters on the broker to say, I'd like it to be. I want this many replicas, or I want it to be put in these distinct geographical locations. So that's the broker. All right, let's talk about Storacha. Storacha is this kind of new hot storage network. Okay, I'm going to whiz through this really quick. It's this, we like to call it like super hot decentralized data at scale. And it's like this idea of using these recipes, using these proofs, and allowing data to be stored hot and ready for retrieval. Our main players here are like our object storage nodes. There are other nodes in our network, like retrieval nodes. We've got this aggregator node. We'll have like indexer and like Fisher nodes to check that everyone's behaving themselves. It will be like an L2 based on Filecoin. It will have storage providers for this kind of aggregation process. They'll be stored in this more durable, longer-term storage by Filecoin storage providers. But the key kind of node in our network is this kind of hybrid node that is a Filecoin storage provider and a Storacha hot storage provider as well. They are both as one, providing the durable, longer-term storage, but also this hot storage layer. So we've got clients. Typically, clients will come along, store some cars. They will send off a kind of proofs of the fact that that's happening. This is a new proof that's being worked on at the moment, of proof of data possession. So the idea that you have access to that data in an unsealed form that is ready to be quickly served to the network, and they'll get rewarded for doing so. Aggregators can come along, ask the L2, what still needs to be aggregated, send off recipes to storage providers. Storage providers can then grab those cars and put them into longer-term deals. And then on the other side, on the read side, you'll have clients coming along and retrieving data. They'll potentially need to, if it's not cached already, they'll potentially need to talk to these hot storage nodes and then submit their logs to the L2 and get rewarded for doing that. And so the final thing I wanted to say was that Storacha is cash for cash. So if you want to get involved, you should check out our website, storacha.network. It's available now to sign up as a node provider. We'll be hopefully launching something like early-ish next year. You can use it right now to store data so if you've got data that you're a storage provider, you've got data that you want to get stored and be available, then you can do do that. We have kind of centralized infra right now, but we're moving towards this network that I just described. Thank you for listening, and yeah.